Hello and welcome to this video on Python summary part 3. So for today we'll go into error handling, functions, matplotlib, numpy, file handling and datetime. Seems to be a lot of contents, so we'll see if I will break this in the middle or not. I might break it into two videos, we'll see. So starting with error handling, we have different types of errors. So we have syntax error, we have runtime error, and we have logical errors. So if we begin with some syntax error, print, I'll just, let's see, print linear regression is a supervised learning algorithm. Run this. Oh, this was in Markdown. So we changed it to Python. We run this one. Oh, name, prin is not defined. Well, yeah, because this was a syntax error and it was actually caught by the editor already. So prin is not defined. Well, because it thinks it's a function, but we haven't defined this function. What were we looking after? Well, we were looking after the print function with t. So I'll change this. Oh, now I fixed it. So this was a syntax error. I'll mark it here, syntax error. So it's quite easy to find. Then we have runtime error. Change it to Python. And runtime error, let's say we do like this. Numbers equals list of range of 5. Then we get numbers like this, right? 0, 1, 2, 3, 4. When we do numbers of 10, for example, it will give us an index error. And this is a typical runtime error, because during runtime it sees that numbers had 5 elements, so we cannot access the 10th element. So it gives back an error. So this is a runtime error. Moving on to logical error. They are a little bit more hard to find, so it requires some debugging skills and some time to find it. So let's start with, we import numpy as np. We see that we need to install numpy, so I open terminal, new terminal, source.venv bin /activate. And remember, if you are in Windows, you do .venv/scripts/activate. So now I've activated my virtual environment and I can do that like this. uv pip install numpy. Also, I will need matplotlib, so I can install it while I'm ahead. So I installed both of them. You see how fast it goes. So I can run this and yeah, numpy works. So let's see, what do I want from numpy? Well, I want to have pi. So radius equals 5, and then we do area circle equals np.pi times radius. Area circle. Oh, magically it works. However, there is actually an error here. I want you to pause the video a little bit and find out what the error is. Okay, welcome back. I hope you found the error. If you haven't, no worries, but actually the area of the circle is pi times radius square. So this is actually the circumference of the circle. So this requires that you know some basic math, some domain knowledge of the area in order to spot this error. So it's not that obvious, and we see that the editor don't give us some error here. So error, let's see, what did I say? Area equals pi times radius squared. That is the true area. And I will show you now, let's see, try except. So we can, when we have code that might fail, we can wrap it around try and except in order for the program not to break. So for example, we can do like this. If we say h equals input, give me your h, and I do float around it. This is valid if I do, for example, 53. But if I run it again and I say hello, then this gives me a value error. However, I don't want this to crash my program. I want it to tell the user not to give this answer. So I wrap it around a try and except. So this is similar to other languages. We have try catch usually. In Python is try except, and also there's a finally statement, which I won't go through. But try and except, what do I want to accept? Well, I want to accept value error. It's good to be specific which type of errors you want to accept. Otherwise, you could, if you catch everything, then you haven't targeted what you want to catch. So accept value error as error. I print it out, print error. So if I run this one, I write 55. We see that cannot convert string to float 55. Great. However, I might not want this to stop my program. I might want to ask again. Well, we can wrap this around a while statement. So while true, as long as this is true, this will run forever actually, unless we break the program. We break the program if this happens. If this is okay, then we break the program. Otherwise, we will catch a value error and we'll type it out. So let's try and run this one. I write something, could not convert to string, and then it gives me another prompt, 44, and it's okay, right? We can also do some other logic here. So for example, if not 0, age less than equal 125. So if the range is outside of this 0 to 125, then we can raise a value error. So we can throw an error, throw an exception. In Python it's called raise. So year must be between 0 and 125. So I can start with some text. So I write some random text, could not convert this to string, could not convert this to float. 126. Well, year must be between 0 and 125. So if I say 125, that's perfectly valid. And we can also do here, before we break it, we can print you are age years old. Run this one. Let's see. 126 minus something. Cannot convert this. And then 120. 12. Let's say 12. You're 12 years old. Great. So this program now handles some errors that can be that can happen when we accept user inputs. So try accept is quite handy in error handling, and it's very good that you also learn how to use the raise statement. So let's move on to functions. So right now we have written all our code in different code cells, and we have usually copied the code. However, it's very good to use reusable parts and use it in different places. This is to organize your code. This is to break down complex programs into smaller parts and make the code more modular. And also something called dry, so don't repeat yourself. And a function is basically, it has the syntax like this. I'll show you. I'll copy this from lecture note. And this one like this. So we have a def statement, a define, and we have a function name, and we have several parameters for it, and we have the colon operator, and we need to have the space for indentation. Indentation is to have scope in Python. Then we have statements after statements. And when we call the function, we take the name of the function, and we put in the arguments. And here we have positional arguments, but we can also have keyword arguments. I'll show you what they are soon. So let's start with the function squarer. Squarer of x, return x to the power of 2. So x is our input parameter. And let's give some naming here. So x is input parameter. Here we have a return statement. And now we call our function. So we do squarer of 3. Then this 3 is actually called an argument. 3 is an argument. So we have a parameter when we define the function. When we call the function, we have an argument, right? So there's slight distinction there. So what happens? This 3 argument goes into the x. And then wherever we use x inside the function, it will replace with the value of 3. So we have returned 3 to the power of 2, which is 9 in this case. So then we could do like this. We could use a list comprehension. Squares equals 4i in range 10, and we could do squarer of I. Squares. Now we see that for each value we put it into this function and it returns the square of each of the value. Cool. Let's have some default value. So def draw ASCII. I'll draw a certain pattern with this. Call this draw ASCII. So number rows equal 5. So this is the default value of this keyword argument. It's called keyword argument when we have a keyword and we have assigned it a value. So for I in range 1 comma number of rows plus 1 print I times x plus number of rows minus I times O. You don't need to understand exactly or I can explain the details here actually. It's not so hard. Draw ASCII, run the function. So what happens here? Well, we print, first when we call this function, it will give the default value of 5 for number of rows. So for I in range 1 to 6, which gives us 1 to 5, because the last number is not inclusive. And we have print I times x. So I will be 1 first, right? Because we start from 1 to 6. So 1 times x, we get 1x plus, then we concatenate the number of rows minus I. Number of rows is 5. 5 minus 1 is 4. Then we get 4 O's. And in the next one, I equals 2. We get 2 x's because we have 2 times x. And then we have 5 minus 2, which gives us 3. Then we get 3 O's. And remember, we have plus, so we concatenate them together. And we use the times operator, the star operators, which gives us repetition of strings. Remember from last lecture. So however, if I want to draw ASCII of another number, for example, I have 7, that is okay. Then I have now overwritten the default value of 5. So number of rows is equal to 7 in this case. And I can also call it like this, draw ASCII of number of rows. I use the keyword argument equals 3. And I get this cute pattern here. Cool. Let's do some arbitrary arguments. So, and also one thing to show here is that we have a kind of a void function, a function without a return statement. So this returns none, but it still gives a printing because we have a print statement. We have print statements inside. That's why we still get output. But remember that we cannot assign this to a variable, or we can, but we will get the value none. We haven't returned anything, but we can return in functions. Remember that. So now we move on to arbitrary arguments, and it's denoted star args. So what this means, I'll give you an example and you will see directly. So let's see mean star args. So this can give a variable amount of positional arguments. So sum equals 0. Why I use underscore is because I don't want to overwrite the functions in Python, because there is a mean function in Python. There is a sum function in Python. And in actually you can overwrite it. It's quite dangerous. dangerous in the way that it can lead to subtle logical errors without you knowing it. So I use underscore to distinguish it. So what I do, I initialize sum with 0, and then for arg in args, I can actually show what args is first. Print args. What will this give us? So if I do mean of 1, 2, 3, 4, 34, right? Mean is not defined, right? Oh, actually, the Python, it's not called mean. np.mean, I think the Python one is called, right? Yeah, np.mean. So Python don't have a mean function. I forgot. But mean underscore, no matter. You see that this is what I got from this function. Well, so I put in 1, 2, 34 as positional arguments, or yeah, positional arguments. And the positional arguments gave me a tuple back. So we have a tuple, right? So this gives me a tuple. Args is a tuple. Okay, let's copy this one. And if it's a tuple, then we can simply loop through this tuple. So for arg in args, sum plus equals arg. So for each value in this these positional arguments, we sum them together. Plus equals is equal to sum equals sum plus arg. So return sum divided by length of args, length of this tuple. Yeah, it might be true, but let's do some simpler one. Let's do 3. Yeah, this is 2. 1 plus 2 is 3, plus 3 is 6. 6 divided by 3 is 2. Great. Now show some quarks keyword argument. So keyword arguments star quarks. So let's do it like this. Import numpy as np. So let's simulate some dices. Simulate dices. Throws equals 1, dices equals 2, and we print it. np.random.rand int 1, 7 because it's not inclusive, the end. Let's see, 1, 7, how large do I want it to be? I want it to be throws, dices. So this last argument is the size. We can actually do it like this, size. So now we use keyword arguments. We can do 1, 7, size, throws dice. Okay, great. Let's simulate dices. Okay, 6, 4. Interesting. So now I just used the default arguments. So what does that mean? That means we have 1 throw and we have 2 dices. So we can see size is based on throws, dices. So we have 1 row and 2 columns. So each dice gives us another column. To show that, we can do simulate dices of 1, 4. Then we get 4 columns, right? And if we do simulate dices 3, 4, then we get 3, 4. 3 rows and 4 columns. Yes. So now we just use the positional arguments. We just take the positions. However, we can do it like this. Simulate dices of rows equals 5. Let's see. If I just take rows equals 5, then let's see what happens. Then let's see what happened here. Well, we have rows and we have dices. So dices were 2. So it was 2 by default. So if I just take rows equals 5, then I get my default values of 2. If I can do simulate dices of dices equals 3, then I still get the rows equals 1, right? So I still use the default value of my keyword arguments. And now I use the keyword arguments because I use the keyword and then I give it a value here. And I can actually do it like this also. I can change it around. I could call it with dices equals 5, rows equals 3. That also works. So I don't need to follow the positions of where they were if I use the keyword arguments. So note there are several ways of doing this. And another interesting way is like this. We could have, for example, options equals a dictionary. I could have dictionary of dices as 3. And we have rows as 3 also. And we could do like this, simulate dices, star options. So this will unpack my dictionary. This will unpack my dictionary and give it dices equals 3 and throws equals 3 into this function. So this unpacking of the dictionary and put it into a key and quarks is very, very useful. So here are some different ways of working with quarks and args. Another way, we unpacked the dictionary here. We could unpack a list also. So say option list equals unpack a list or a tuple. Let's do a list 1,5. We could do simulate dices of when we unpack a list, we do it with 1 star. Yeah, exactly 1,5. Cool. And there's one more thing I want to show you in functions, and then I think then I will cut this video off into 2 parts. So let's go into lambda functions. So for lambda functions, it's anonymous functions which can take many arguments, but it has one expression. And it can be used inside other functions. So lambda x to the power of 3, lambda x colon x to the power of 3. Let's see. All right, we cannot do it like this. We should do it like this. Let's say f equals this, f of b. Yeah. So this is we created this lambda function. It's same as writing def f of x return x to the power of 3. this is equivalent. However, let's see, we need to format it a little bit nicer. Let's see here. So this is the same. We have created this using the lambda notation, and what is interesting here is that you can actually pass lambda function into other functions so that they can use it. I can give an example of this. Let's, for example, we have I'll copy this from the lecture note. We have students with different scores. So this is basically a list of tuples. And if we want to sort this, we could do like this. Sorted of students. And what happens here? When we sort it like this, we sort it by the... we can make it more interesting actually. We move this Alice to the end. Like this. Yes. And when I sort it, it gives me a sort based on the first argument here, and it's based on the first letter. However, can I sort it based on the score instead? Well, then I need to put in a function and tell it how it should sort it. So sorted of students, comma, key, they accept it as a function. A custom key function can be supplied to customize the sort order. Interesting. So the key here is to use lambda. So lambda of this student, and the argument of the student, I want to have it as 1. So then it's based on this value instead. So now we have based on the scores. And also I can do reverse equals true. And then I get it as descending order and not ascending order. So here we put in an anonymous function. So this function is basically saying that we will return the first element of your list or tuple. This is basically what it says. So I don't need to create this function beforehand and then put in the function. Instead, I can use the anonymous function, the lambda function, and put it in directly. So the sorted will take this function and it will then it will sort based on the first order or the first position of each of the tuples. And then I will use it and use the reverse function, reverse keyword argument to reverse the order, to have it descending. Okay, thank you for this video, and we'll see you in the next video where I'll cover matplotlib, numpy, file handling, and datetime. Probably we'll cover all of them in the next video, but it could be separated into 2 videos. We will see also. Okay, thank you. Bye.